Today on FPV 101, we're going to be talking about how to choose the right motors for FPV. So when looking for FPV motors, you have two different types, brushed and brushless. Now, a set of brushed motors such as these are usually found on micro drones. The reason for that being, brush motors don't have a very long lifespan, and they're fantastic for beginners being that they don't generate too much thrust, which will allow you to get a handle on the flight mechanics way faster than if you had something like a brushless motor. Now, the one drawback with brushed motors is that they degrade over time and will eventually stop working completely. Now, for more professional flying, you can switch over to brushless motors. The benefit behind brushless motors, you'll have more power, more torque, and if you don't crash too much, they can last you for years. One thing to watch out for when using faster, more powerful motors is the Ampere rating on your ESC and your PDB. If using a PDB and 4 single ESCs, you're going to need to swap out each individual ESC and your power distribution board for a higher rated one. Whereas you can just switch out the 4-in-1 if you use this system. Now, the benefit to running 4 single ESCs, such as here in a power distribution board, is that if one of these components blow, you can just take it out of the system and replace it. And it's a quarter as expensive as if you blow something like this, a 4-in-1 ESC, where if you blow something here, you have to swap out the whole board. When choosing a motor, size is usually dependent on the size propellers that you want to run. The size of a drone motor is defined by 2 main parameters, stator width and stator height. A stator is the stationary part of the motor, or the base of the motor. And then you have your rotor, the part that actually spins the propeller. And when you put them together, you get your brushless motor. Coils in the stator, as you can see here with these copper windings, take on different polarities that attract or repel the magnets within the rotor itself. This is what causes the motor to spin. Let's say you have 2 motors rated at the same kV and they have the same stator width. The motor with the shorter stator height will be more efficient, which means it'll pull less current, while a tall stator will give you more torque and less efficiency. And lastly, always make sure you look for the motor mounting dimensions to make sure that it's compatible with your frame.